Okay, let's first take accuracy. Okay, so here is our classification matrix or classification confusion matrix. So actual class C1 and C2, predicted class C1 and C2. So the misclassification rate here is the off diagonal. Okay, like actual is C1, but we predict them as C sub 2. Okay, so that, and actual is C sub 2, but we predict them as C sub 1. So if you add these two, that would be the total misclassifications we have made. And you divide by the grand total. So n here is the sum of all of these numbers. So that's the total number of observations. This gives us the ratio of misclassified records. So that is called misclassification rate. So the accuracy rate is 1 minus that, so which is the diagonal case. So if you take C1 getting classified as C sub 1, so that's good. That's accurate classification. And here again, another accurate classification. So add those two and divide by n, that gives us accuracy. So the accuracy is always 1 minus the error rate or misclassification rate. Now you'll see misclassification rate as the default for many of the methods that we will be discussing in SAS. But you can always select a different measure instead of misclassification rate. But misclassification rate is the default. Okay, let's look at a numerical example. Okay, suppose we have a classification confusion matrix where we have 3000 observations, of which 286 is actual class 1, 2714 is actual class 0. So predicted 1, predicted 0. So the accuracy rate is along the diagonal. So 201 plus 2689 divided by 3000. So misclassification rate is going to be 1 minus 0.9633, okay, which is the off diagonal divided by 3000. Now let's look at sensitivity and specificity. Sensitivity is the ability of the model to correctly predict class C1 or the event of interest, class equal to 1. So that is sensitivity. So that is, given the actual class is C1, how likely are we to predict it as C1? So this is a conditional probability as opposed to the accuracy rate and misclassification rate that we saw previously. So this is of all the actual C1. So all the actual C1 is the sum of these two. Okay. Of those, how many as a proportion did we actually predict as C1? So that's the number that we predicted as C1. So that goes into the numerator. N sub 1 comma 1 divided by the total. Now let's look at a numerical example. So same classification matrix. So here the actual 1 is this. Okay, remember this is the event. Sensitivity relates to the event. Class equal to 1. So 201 divided by 286. So that gives you the sensitivity. In medical terminologies, this is very important because if you're trying to diagnose a disease and if the event is the presence of disease and you want the diagnostic technique that you're using to be very sensitive, should be able to predict the cases, the events very well. So you want very high sensitivity in these cases. Now specificity is the opposite in conceptual terms. That is, now we are going to talk about the non-event, C sub 2. So given that that we have a non-event, what is the likelihood that we will be able to predict the non-event correctly? So probability of predict C sub 2 given the actual case is C sub 2. So actual C sub 2 is the sum of these two. So that goes in the denominator. And this is the number actually gets predicted as C sub 2. So that goes here. So same example. So now 2689 is the correctly predicted non-event of all the non-events of 2714. So this is like false. This is like if there is in medical terms, if the patient is free of the disease, so it is a non-event. What is the probability that you're able to detect that? What is the probability that you will be able to diagnose as a non-event? Then there is two more, which are false positive rate and false negative rate. Now these sometimes are interpreted wrongly by a lot of people. Okay, so this is about of all the events that you have predicted, okay, how many of them are not actually events? So given you have predicted as C1, of all the predictions that you have made as an event, how many are non-event or in proportion? So actual C sub 2 within those that have been predicted as C sub 1. So this is also conditional probability. So this sum, okay, that is in the denominator of those, what is C sub 2 goes in the numerator. This is your false positive rate. So here is the example. So 25 divided by 226 will give you false positive rate. Now false negative rate is of all the non-events that you have predicted C sub 2. So all predicted C sub 2, among them how many are actually events? So n1 comma 2 divided by that sum. So that's false negative rate. So this should be false negative rate, FNR. Okay, so here of all the non-events, okay, how many are events? 85 divided by 2774 gives you false negative rate.